Hello and welcome to this video on singular value decomposition reduced order model using Fluent and Twin Builder. We have a battery module here with 12 cells. It has a cold plate at the bottom, and this will be used for training a model. As you can see here, I ran the flow only simulation to get a flow field simulation distribution for the cold plate. We'll look at the battery model. So it's using CHD coupling, Joule heat transfer is activated, display the active components, and then the passive components. In terms of electric contacts, there is a negative and a positive terminal. And looking at moving forward into the ROM, we'll set all of these to 0. So both the energy source as well as the tab current. So we'll apply that. And we'll go to the advanced options, go to the battery ROM toolkit, switch the ROM type to SVD, click on volume heat, use a filter to get the cells. And here I like to put the value in before using add individually or add as groups. So in this case, we'll add as a group. Now it's there, we'll click on OK. We'll add tab current, put that 100 amps. And for the exported temperature zone, in this case, I'll just add everything. On OK. And then maximum time step size, I'll double that to 200. I think leave everything else the same. Click apply, and then start the training by clicking on run training. And this will go maybe almost about a half hour for me. I'm running 10 cores, so we'll see in a little bit. And we're back from the training runs. So you can see that the training runs indicates the training runs have completed. So after this, there is a new directory that's formed, SVD. I recommend making a copy of that, putting that into a copy name SVD copy. And so this is the file directory that'll be used for the Twin Builder simulation. Now, once we open up Twin Builder, we'll go to the Twin Builder menu, go to the toolkit, go down to SVD ROM identification. There's two inputs. One is the power, one is the current. So we'll increase number of inputs to 2, and then I'll tweak this relative error by a little bit. And then do a generate, wait for that to complete. And once this is complete, we'll hit any key, click OK, and close here. And then in the project components, there is a new component. Drag that in, zoom in a little bit. We'll add a constant for the energy source and a constant for the current. Escape out of that, and we'll add a square function to take the current and multiply it by itself. We'll do the connections. A little bit. Adjust the value for the constant value. We'll put 120 so we can have 10 watts per battery cell, and we'll increase the current also to 100. And then go to, let's see, output dialog, make sure all the outputs are active, so all the check marks are there, and this defined output, they're here, so we're good. Go into the analysis, results, create a standard report, rectangular plot. We'll select all of these ROM outputs, new report, close that. Then go into Analysis, TR, do an edit on that, change the end time to 30,000 seconds. Minimum time to 0.1 seconds. And the maximum to 10 seconds. Right click on PR, tell it to analyze. So that took about less than 2 seconds. So right click, do an export. And we'll export out a CSV file, but this time we'll export uniform points. We'll do a start at 0, a stop at 10,000, and then every 200 seconds we'll output. So click on save. And we could write out the twin builder file here. That's something we could do. And I think we're done with the twin builder. So next we'll go back to Fluent. So we'll go to Fluent, pick on models, battery model, go to the advanced options, pick on the battery ROM toolkit. Now we'll go to the ROM post-processing, pick one of the basis files. So I'll pick the one for joule heat. And then for the transient coefficient file, I'll pick on the CSV file. And then there should be snapshots every 200 seconds. Let's pick on one of the later ones. Do a compute. And then once that appears to be done, we'll go to the contour plot to edit on that. And this time we'll switch, instead of contours of temperature, we'll go to the user-defined memory. We'll do SVD temperature, keep auto range on. Save display. Looks like it's a little bit above 315, so I'll increase to 316, turn the auto range off. Save display one more time. I can close that. I can go back over here. I can generate animation images from that contour. So here I'll click on create, and then we'll wait for all of the images to be generated. There should be about 50 of them. And the range for all of them will be 300 to 316 Kelvin. Although the time is not incrementing in the title, it is doing this every 200 seconds. So that took about 2 minutes. And the result would be that we have a new folder, animation images, about 5,150 files. This completes this video. Thank you for watching. Bye-bye.